We are here with a panel now. We are going to talk about emerging technology and embedded IoT. So I am here with Khuong, who is Senior Product Manager for IoT Solutions from BICS. I've got Scott Radwan, who's the Senior Product Manager from the Wi-Fi Alliance. I'm here with Dan Klaeren, who's the General Manager of Americas and VP of Sales for Ignion. And so the first thing I'd like to talk about, it's something that's been very exciting for me over the last year, is the rise of Matter. So beginning of January, CES, Matter, we're going to have a specification this year. Okay? The months tick by, no specifications forthcoming. Finally, October, it comes out. It's very exciting, and we still don't know exactly what's going to happen with it. So I think the first person I'd like to ask on this is Scott. Say, from Wi-Fi Alliance point of view, from your point of view, how do you think Matter's going? How do you think it's going to? What do you think is going to come with it?
Yeah, sure. Well, that's a really good question. We get asked that a lot, quite frequently. And since they announced October 4th, their specifications have been released on their sites. And it's moving, I would say, organically as we expect. The test labs are getting configured with the equipment to start doing certifications. Their member organizations are coming on board, and we work with them at Wi-Fi Alliance. We work very closely with CSA on Matter, and as a matter of fact, to be Matter certified, the device also needs to be Wi-Fi certified in some form of MAC-PHY certification. So we're very excited about that, and I'll just say that because there's oftentimes questions about how Matter and Wi-Fi Alliance will interoperate together, and that is this: that Matter, if you don't know, it works within the application layer of the software stack, while Wi-Fi natively works down at the physical layer. So it's really a good fit for both alliances to work, and so we're excited to be a part of helping Matter grow, because the benefits of what Matter is going to do is bringing a fragmented ecosystem together in such a non-fragmented way. I think is going to be beautiful for the entire IoT ecosystem, particularly in the smart home environments.
And then Dan, do you have anything to add to that?
Well, I will not profess to be a Matter expert by any means, but from my understanding of the project, it's all about interoperability. And this really gets me excited, especially with my counterpart over at BICS. I've spent 20 years in interoperability. I've worked with the Wi-Fi Alliance, the Wireless Broadband Alliance, and I had the interoperability hubs over at Cineverse. And the idea about making it simple for devices to be able to connect to each other and interoperate and put the power in the hands of the developer to be able to interconnect between these, right? Because it's all about going into the home, into other places. Right now, it seems like you're either an Alexa shop or a Google shop or whatever shop. But to have a single hub in the house and have these devices interconnect between them and enable the developers in the ecosystem to be able to interoperate is a big piece. And it's going to start out in that 2.4 frequencies. But I suspect that it's going to go down at the sub-gigahertz frequencies with ISM to try and further get into the house. So it's all about being able to connect those ecosystems, because if people are acting in individual silos, you won't get that great experience and you won't get the speed to the market like you can if you have smooth interoperability between them. So we need investments into Matter, Amazon Sidewalk, and initiatives such as that.
Yeah, I think one really interesting point with regards to Matter is that it does have that Wi-Fi standard, and what building doesn't have Wi-Fi these days? I think that's really when we're looking at sort of connecting things in the home. It's the obvious place to start.
Well, my mom could use Wi-Fi. My mom's 90, right? And Wi-Fi is easy. Wi-Fi is simple. Everyone knows Wi-Fi. It's a big brand that's out there, and you can connect to it. One of the challenges with Wi-Fi, though, is historically, you can make a lazy device, and what I mean by that is you plug it into the wall, right? Everything has power, right? And then now once you begin to get into mobile devices, you got to be worried about power consumption, right? And you got to tune it. So that's where you need those lower power Wi-Fi devices, right? More efficient, and that's where we come in over at Ignion, focusing on RF connectivity and making sure that you're spending your battery wisely on that device and you're getting longevity, because nothing's more annoying than your son or your daughter in the car and the battery of the device goes out, or in the house, or wherever you are with Wi-Fi. So as you continue to evolve into Wi-Fi, Wi-Fi is here to stay. Wi-Fi continues to evolve with great standards, more and more capabilities, more and more security. Now it's about the involvement of the devices to be able to make it more mobile in the house and less attached to things and last longer.
And there's another, while Wi-Fi is wonderful, we do sort of have this other need for long-range connectivity in the IoT. And in Quan, how do we sort of, so if we're going to reach outside the home, okay, yes. So what's new this year and next? What do you think is coming in that arena?
So on one end of the spectrum, you have technologies such as Wi-Fi, who provides very good, I would say, data speed, doesn't consume too much power, but has quite a limited range. We talk about hundreds of meters. On the other end of the spectrums, you have typical, I would say, cellular technologies such as 2G, 3G, 4G. They consume a lot of powers, unfortunately, but they provide a bigger range and decent data speed, I would say. So there was a need to have something in the middle. I mean, not all IoT devices need to have a lot of, requires a lot of data speed or bandwidth. So 3GPP actually launched a few years ago, LTM and NB-IoT technologies to address those LP1 devices. So NB-IoT was designed really with 3 key drivers, I would say, in mind. First one, this was to enable massive IoT connections. So we talk about hundreds of thousands of devices within one cell. I don't believe that Wi-Fi is able to cope with that. Then it was actually supposed to, as well, to minimize the power consumptions. So and the data speed was could be very low. On the other hand, you have LTM, which also aims to really lower the power consumptions, but provide a better data speed. So we talk about 1 megabit per second versus 200 of kilobits per second for NB-IoT. But the most important things of that LTM brings was actually to ensure mobility. So it allows a handover of different cells. So at the end, and some of our IoT customers are confused, LTM and NB-IoT are quite complementary because they address different use cases. So if we look now at the footprints, so how many operators are actually supporting today LTM and NB-IoT, we saw slower adoptions of NB-IoT versus LTM. So because NB-IoT requires to change complete the radio technology stack. It's based on 2G and 3G network elements, while LTM is based on the current LTE infrastructure, which is widely deployed, and just requires some changes on some mobile network core elements. So, for example, at BICS today, and because we are talking with all the operators all over the world, we are able to provide 50 plus destinations of LTM versus 15 to 20 NB-IoT destinations only. So it takes much more time for the operators to be ready with NB-IoT. And just to complete the whole technologies on the radio cellular side, we have 5G, obviously, now, coming up to address really specific use case where you need very ultra-low latency. There you need to differentiate between 5G non-standalone and 5G standalones. It takes a lot of time for the operators to be ready with a standalone 5G. Non-standalone, it just actually requires to put new antenna, 5G antenna, but it's using the current 4G mobile core, I would say. So the speed is quite different. With 5G non-standalone, you can achieve 1 gigabit per second, which is very similar to the Wi-Fi, 11 AC. I believe it's 1.3 gigabit per second. But with the standalones, 5G can achieve up to 100 of gigabit per second, which is very good, I would say. Okay.
So I think there's the eternal question is there's power consumption, there's bandwidth, there's latency, there's penetration. At the moment, it's sort of, 10 years ago, it was sort of pick one. You could have one of those things. Now we're pretty much to the point of pick two. I mean, so how do we, I think that's going to evolve. Do you think we're going to have more sort of medium-range solutions that sort of do a little bit of everything well? We're going to have some long-range stuff that's low power and also adequate bandwidth. There's sort of, what's the next stage in that sort of evolution? I'll pass it over to Dan, if I may.
Yeah, that's a real challenge. So, and on our end, because we deal in RF, we're getting a lot of multi-band products, meaning that people are seeking a narrow band plus LoRa plus Wi-Fi to try and cover it all, because there are so many different standards that are out there, or not standards, I should say, but access to different networks. It depends upon the use case. And now we've got more and more satellite coming down now as well. So, I mean, on our end, we're just trying to balance it back and forth. I'm not sure how things turn out with the unlicensed and the licensed spectrums. I think a big key is BCE, and not to go into that piece, but how the roaming between the operators take place for the narrowband and the LTE-M type of pieces, and then people still wanting to stick to the unlicensed spectrums to be able to have no-cost networks. But then you've got hubs. So I expect it to be, the next couple of years or a bit of a continued scramble to figure out which technology takes place, and most people trying to hedge their bets on all sides of the fence or what makes sense in their local area.
And then sort of Scott, from a Wi-Fi perspective, that end, how do you?
Happy to speak to that. So for Wi-Fi Alliance, presently Wi-Fi 6 is out in the market, and it's really starting to gain traction, and it really hits all of those spots quite well. With Wi-Fi 6, 2.45, and then even 6 when you include 6 gigahertz in that range, which really opens up the performance quite a bit. But also there's improvements within Wi-Fi 6. To talk to your point, low power, the Alliance has spent a lot of time with tuning target wake time, which really improves the performance all the way around, from battery life all the way to the efficiency of how bandwidth is handled from device to device by managing when APs are working with each other and not. And so Wi-Fi 6 is really a tremendous technology for IoT, regardless if it's in the home or in the industrial IoT sector. And so really happy with that. And then we also have Wi-Fi Halo, which is an important technology that's not talked about too often, but ultra low power in terms of battery consumption, and operates down and below the 1 gigahertz range, but can get accurate throughput out to really far ranges, so hard to reach places. And so that's a technology that we expect to see grow over time.
Throwing it back to some extent to Matter, I really think in the industrial space particularly, we could see some sort of stack of Wi-Fi with Halo and sort of getting a lot of the same. You get the close coverage up strong, you get distance coverage. It really ticks a lot of boxes. I'm really excited about Halo.
Yes, yeah, and we are too. We just came out of a member meeting, and that's what we expect to see in the future.
So let's look at some actual use cases, because we like to talk a lot about the big sort of airy-fairy pictures of things. Let's talk about twinning. This is something we talk about a lot. And Dan, I'd like to talk to you, if you could start, let's talk about like what is a twinning, sort of digital twin? How does this relate to the connectivity aspect?
We're very excited about digital twinning ourselves. So we've done a heavy investment into the AWS space to be able to provide a digital twin. And what I mean by that is people are trying to develop devices faster, more secure, and better than ever, right? And it used to be that it was an individual trying to figure this out at a computer. But our digital twin is an RF twin, RF design twin. We were able to submit into there very basic information. Here's the size board I want to use Wi-Fi, and I want to use narrowband IoT, and our digital twin will go off. It'll come back and say, all right, well, here's the part, here's the placement, here's the bill of materials, and if you do this, then here's the performance you can expect. And why that's important in the RF domain is a lot of times people are doing designs, and at the end of the day, we're going to say, well, then I'll connect an antenna. Like, I have a device that can do 50 different things. It's beautiful, but I'll figure out RF at the end, and people are bumping into a lot of problems as far as now I go to connect. But with the digital twin, in this example, you can come back and say, all right, I'm already at my performance mark. I know I can proceed. And it's more and more things like that that makes things faster and easier and smarter for any level of type of work that you're trying to do, in particular for us, RF design engineers.
I think, Quan, can you talk a little bit about you spoke to us earlier about sort of the connecting twin, and I'm sort of interested to hear your perspective on that.
Yes, connectivity twin. So at BICS, we were also very excited that more and more of our customers are using digital twin and device twins provided by hyperscalers because of the facility to host and scalability and plug-in templates that can be used. So we're just wondering how we could actually simplify their life with connectivity, cellular connectivities. So today what is happening, so because digital twin and device twin is more focused, on device property, device data from the different sensors, but not really on the connectivity. So if they have any issues, they would have to go to the CMP, so the connectivity management platform of the operator, to try to find a little bit which SIM was inserted in which device, and what is the issue. So the idea of connectivity twin is we would bring directly connectivity data directly into the digital twin as a plugin that they could use, they can install from the marketplace. So it's not only about making the connectivity data available on the digital twin, it's also helping them to better understand what is behind connectivity, because usually customers are enterprises, they don't understand the telco, vocabulary. It's quite complex. And it's also about how we can actually help them to, link device informations and cognitive informations to fulfill some specific use cases. I can give an example, like some of the customers, they have trackers, and that runs on battery. And it takes a lot of time for the trackers to acquire the GPS coordinates. So what we can do is provide directly into the applications the coordinates of the cell ID that we can provide via our connectivity data. By actually using the cell ID coordinates, it can speed up the GPS acquisitions of the device. And there are plenty of examples where they can look at the connectivity data to really fulfill some specific use cases, I would say.
And then, Scott, do you have anything to add sort of about twinning or this sort of application?
Well, Wi-Fi will be happy to help connect the twins. That is for certain. But another important point, though, is what at least I've seen out in the service provider operator world is twinning in terms of the network configuration for APs are out in the cloud, and so in the event of any type of misconfiguration in the home or in the environment, the config is easily pushed down to the cloud, and that's a great use case for the definition of twinning, and at least in my mind.
I also think I'd like to sort of see connectivity and security, for that matter, built into the equation much, much earlier on. I think in the design process, sometimes connectivity and security both get sort of added in at a later stage. We'll see what's available, and then we'll make that fit. And it would be nice to see with a sort of twinning model, sort of take that data and see what works in a later stage and sort of apply it somewhat earlier, and sort of build the connectivity in from the die would be ideal, but at some point after that, some sort of earlier on, and so we can sort of get the best solution for the best product. So all of this that we've talked about today is going to need a fair amount of enabling technology of some kind. There's going to be, to get to what we see, we need to have 2 or 3 other steps along the way. We're going to have to develop tech to develop our tech. What sort of enabling technology do we need for this sort of activity? So Quang, you could sort of start and talk about that for us.
Yeah, okay. So what I would like to talk is how we can help our customer, to deploy massive IoT devices all over the world, right? And we believe that eSIM is playing a key role in that area. So why? Because if you want to, deploy massively IoTs, you need to simplify as much as possible the manufacturing process. So our customers just want to handle with one type of hardware that can be shipped everywhere, and it's going to be the same with the connectivity. It doesn't make sense for him to contract with different MNOs, having different SIMs to manage from an inventory perspective, and in the supply chain, he has actually to choose the right SIM with the right operator or mobile profile. It doesn't make sense. So we believe that eSIM is a solution for that, because it could embed a kind of global profile, bootstrap profile that we call, that allows the device to get connected everywhere it's shipped. But you don't want to be stuck with that initial profiles, right? You need actually to be able to change another profile because of permanent roaming issues in some of the countries, or if you want to optimize, the cost in some specific countries. So you need eSIM for eSIM. So, and in eSIM there are 2 flavors. There is eSIM for machine to machine versus eSIM for consumer, which is very different technologies that runs behind that. So eSIM for consumer, everybody know in high-end smartphones, you know an embedded eSIM that you don't see, which actually relies on SMDP Plus platform and LPA logic that is on the device. And the provisioning setup is super simple, so everybody can actually activate the profile. You just need a QR code and the LPA into the device. We just translate the QR code into a URL of the SMDP Plus and some activation code, so the device can automatically go to the SMDP and fetch the profiles. So very easy setup, everybody can use it. But eSIM for machine to machine is much more complicated because the topic is about IoT, right? And we see that the reality is it's very difficult to set up eSIM for machine to machine ecosystems. It requires actually not SMDP Plus, but 2 platforms, SMDP SR. And if you want actually to switch one profile to another profile of the operator, you need to integrate the SMDP SRs of all the different operators. So that integration is quite costly. It takes usually from 4 to 6 months. Not everybody is willing to put money on this. And if the more that you actually try to put local profiles, but the more you need to integrate with all the operators. So that's why at BICS we see that most of the customers, when we explain that challenge, they said, okay, I'm happy to stick with one global profiles, but they can still actually, for example, use a eSIM for machine-to-machine as an insurance policy. So the day that they want really to have another profiles and they have the money to invest, then they can go and do. Now, GSMA is well aware of that kind of challenges. So they came up they're working actually on a new standard. So Workgroup 7 from GSMA is actually thinking about reusing the SMDP Plus solution, so from the consumer side, but to apply on the IoT use cases. So it looks promising because the high-level guidelines would be that they want to reuse as much as possible the SMDP Plus, so without any change if possible, and they want to translate the LPA, which is in the smartphone, as an IPA that we'll put in the SIM or into the devices. So if they succeed to do that, it means that we can just reuse the existing profile from the consumer side for the IoT devices. So in terms of timelines, the specs will be ready in 2023, so next year, with some working solutions from SIM vendors in 2024. So this, and I hope that with that new, I would say, framework of solutions, it will really accelerate the adoptions of eSIM into the IoT ecosystems.
Yeah, absolutely. Dan, please do.
So yeah, when I think now, it's interesting with the eSIM, because I'm going to equate it back to my products as well. And this is what I think we need. So digital twins to help you do things faster and design it better. Now, if you think about eSIM, what we're doing is you're adapting to the environment that's out there in a way that's embedded, meaning it doesn't require manual functions, right? So if you think about traditional SIMs, okay, I want to switch networks, I got to pull the card out of my phone, I got to put a new one in, then I got to connect to the network and whatever, right? And eSIM takes care of that for you, right? And if you think about our technology with our antennas, it's adaptable, meaning that back in the day, if you wanted to switch to a different frequency, you got to get a different antenna, right? So, but with us, you're able to adapt it by changing a few simple components. So my point there is you've got to have adaptable, flexible technology, and then you've got to have products such as Matter or interoperability pieces, right? And you got to have highly available, sophisticated networks that can take that on. And by the way, most people don't realize Wi-Fi, you can choose your security level. A lot of people just think it's username and password, but you can do 3GPP standards for security. It can be incredibly secure. So, long story short, digital twinning to get things done faster. Adaptable technology that's reliable and embedded so people can't, not only easier, but you can't break the device, right? And then you've got strong technology on the back end to be able to support the receiving the radio waves, and then interoperability with the likes of Matter so you don't have as many hubs and pieces in your house, right? And that's how things are going to continue to evolve, and it's how we're really going to streamline and make people's lives better.
And Scott, from a Wi-Fi point of view.
Sure. Yeah. So Wi-Fi Alliance, our pursuit is pervasive, persistent connectivity to everything, everywhere, and we're pursuing that through Spectrum, and it's a constant involvement by our leadership, and it's very exciting stuff that is happening. And everything that I've heard here at this conference is data-driven, hyperconnectivity. And with Wi-Fi, we believe that is the fabric that this data can traverse on, particularly as we evolve. Wi-Fi 6 is out now. It's a great solution. It's really gaining momentum now, even through some of the problems that we've had with trade tensions, COVID, and supply chain. But it's coming out now. And then when I say with Spectrum, we've got 6 gigahertz out now. It's still early on, but it's gaining momentum. It's a tremendous 160 megahertz spectrum that that has massive amounts of throughput. Great for backhaul, eliminating congestion for front haul, and then it's a stepping stone to get us into 7. And then there's just great things that we're working on going forward. So. The Wi-Fi Alliance, we're very excited about our future, particularly with Spectrum that's coming available.
Yeah, I'm huge. Obviously, the 6 gigahertz spectrum. 6E is impressive, and I think it's getting a lot of sort of things out there. But 7 is going to people are going to log into 7 and go, wow, because it's going to be
160
it's such a
to 320
game-changer.
megahertz. So yeah, it's even wider and faster and more
And I
persistent.
think there'll be the technology, people will be using augmented reality devices in their homes and be able to use it with 7 and sort of see how fast it is and how it won't ever be quite as fast as plug-in because plug-in keeps getting faster. But I think it will show, and the amount of devices that you connect, the speed that you can connect is going to be unbelievable.
Yeah, true. Yes, I'll leave it at that.
Okay.
I'm on guardrails, so I
Okay.
need to be careful about
Sure.
what I say. But yeah, XR is very important to us, and
Okay.
we're excited for the future there too.
Okay. Well, keep the mic for a sec. Let's. It's a year from now. Okay, we're going to get our crystal balls out. What do we look back on and say, this is what happened this last in 2023, and this is what's going to happen in 2024, 2025? How do you think things are going to evolve from your perspective, from your companies or your alliances?
Yeah, in my role, from my point of view, right now is I do believe that 6 gigahertz is going to continue to gain momentum. We're seeing now just Wi-Fi 6 chips. They're starting to propagate out, and so I'm expecting to see Wi-Fi 6 being fully embraced in the IoT space, both in home IoT as well as industrial. And yeah, and without going too much, I'm excited to see what happens this time next year. You know, when we're able to announce 7.
Quan, you wanna?
Yeah, so on my side, so talking about, from a cellular connectivity solutions, for sure there will be more and more support of LTM and BOT from the different MNOs. And our IoT customers will have a better understanding on when to use LTM versus NB-OT, and we'll be there to guide them into to make the right choice, I would say. But next to that, obviously, eSIM will continue adoptions, especially for enterprises who have the means to invest in that ecosystems. But there's also something else that I didn't mention. It's IoT Safe. So IoT Safe, it has been standardized by the GSMA 1.5 years or 2 years ago. And actually, it's a very nice solution to help customers to secure the device solution. So, traditionally, the way to secure a device, you need to put, certificates and PKIs into a secure elements into the devices. So the device actually can use them to establish the TLS connections and get authenticated at the applications in the cloud or in the premises. And that process is quite complex because you need to foresee in the supply chains to inject the keys. So GSMA came up with the idea to reuse the SIM, which is already a secure element, to host those keys. So this is a new technology appearing 1.5 years ago, and I really believe that if customers are aware of this, they might actually consider using the SIMs to secure the devices.
Yeah, Dan.
What I expect to see is more accelerated developments in 2023. And the reason why I bring that up, and it's completely off topic, is supply chain has caused a lot of problems with people to be able to create new devices. So we've got a lot of people that are still stuck adjusting to the supply chain in old devices. But what we're seeing up now is supply chain is getting easier, and now people are beginning to turn their attention to the new devices, and people need to get those devices out faster because they should have been out last year. So you're going to see more investments in the twinning and how to get things done faster. You're going to see more development in the space of long-range technologies to be able to track more assets, and more investments into the interop space, especially, like, not to bring up Matter, but technologies like that to be able to make them more seamlessly interact, whether I'm a business or I'm a consumer. Again, less hubs in my house. And that's one of the challenges that you face is different technologies require different hubs. So how do you have one single hub that can address all those technologies? So more investment in that space to be able to make things more inoperable.
Great, terrific answer. We have a little bit of time now for questions. If anyone would like to ask a question for any member of the panel, anyone? I will come down. Anyone? Any hands?
Yeah, I was curious. I've been following Halo and kind of seeing the progress being made there. It seems like Morse Micro is one of the companies, vendors that has a chipset, some products showing up. Are there other vendors who have committed that we're expecting or announced to see that broaden out? And are there sort of next steps that you're looking at with Halo?
Well, thank you for the question. And what I can say there is there are next steps. The members that are involved in it, that's confidential information, but it is there is more next steps coming with Halo.
What do you think would be something that really sort of kicked Halo a bit further forward? What would be the drive? Because I don't see, for a fascinating technology, it hasn't quite caught the imagination the way that Matter did, and that's probably just a case of marketing. But what do you think would really, is there a use case that would push Halo forward, do you think? Or is there?
Well, yeah, the use case is long range, low power consumption, hard to get places, and that's a use case, and maybe some of that has been hampered again by trade tensions, COVID, and supply chain, and so and Wi-Fi Alliance now is in full steam with our member meetings, and the task groups are in full force. So. As he just mentioned, we expect to see more innovation coming up in the near future, and we hope to see that Halo is one of those technologies that come out.
The more we hear about it, the better, because I think it's really going to be
And that's good to hear that too.
Yeah, absolutely. Any other questions? Everyone's very hungry, I think. Okay, well, it remains to me to thank to Quan, Scott, and Dan. Thank you so much for joining us, particularly Dan, who stepped in at short notice, did a fantastic job.